looks like I am live now. So I'm going to go ahead and get started because 20 minutes is so short. So what I'm going to talk to you about is the evolution of architectures over time to try and unite the worlds of the BI analyst and the data scientist. I really strongly believe that technical and spiritual unification of BI and data science can make a powerful impact on the effectiveness of analytics for the business overall. And I'd like you to see that as technology progresses, we are really trying to make that happen for you. So next slide. I had some technical difficulties, so I have someone changing the slides for me. So I'll have to say next slide when it's time. All right, so let's look at the data warehouse architecture. I've been in this business for 23 years, doing engineering and consulting and being an analyst and data product marketing and product management and all this stuff. And this architecture outdates me. For over 30 years, this architecture was the way to do business intelligence, to do reporting, to keep an eye on your company, and to make decisions based on data, not on guesswork. Now, the power of it, go ahead and go to the next slide, is that it has several strengths. And that's why it's been so, has so much longevity. And it also is very mature. It has a lot of reliability and security and governance and things like that from being around for so long. But the power of it, the reason that it's been around for so long, is that it has truly high performance. You can get sub-second responses from your database, and you can get it on all the data that matters for your company. At least you could back in the day. And you could do it in high concurrency, which meant not just the 10 people who knew how to build dashboards and visualizations and things like that, but all 100 or 1,000 or however many people that they sent those dashboards out who could point at the thing that was interested to them and click on it, and it would send a query automatically and they would get an answer. So this is the ability for every single person in a company to do their job based on data and not on guesswork. So BI is a very powerful thing, and it uses SQL. Okay, well, so your business analysts, they're pretty comfortable with SQL. As a data scientist, you should be pretty comfortable with SQL too, because it is very foundational and it is something you're going to have to learn as you go along. Go ahead and go to the next slide. But it had some weaknesses. Obviously, the concept of the database was created so that a person could it could do BI on a certain amount of data, and it was very clean and it was very structured. And this was great, but it didn't work so well when you had this explosion of data and high speed streaming data, and you had all these new types of data like JSON and Avro and semi-structured data and all this information is coming in, and you needed a place that you could store it that scaled inexpensively. So that's where the data lake kind of came around. It's got this ability for you to put whatever kind of data in there. And then we had the capability to do that ETL, do that data preparation with something like MapReduce or Spark. And then we put it into a data format that was queryable, not fast, but you could query it with SQL, but you could do some new things. You could do machine learning, you could do data science, and you could use some other tools. Now, you could use Spark in particular. The problem is that a lot of data scientists want to use R, or they want to use Python, or they want to use a Jupyter notebook that can kind of translate, or with some other kind of notebook. And the problem with that is what you ended up with was data scientists that would take a sample of the data and go work with it somewhere else, something small enough that R can handle it or Python can handle it. Now, the problem with that is you had some accuracy issues and things like that. But overall, it still gave you some capabilities that you didn't have before. And you had concurrency issues. So you only had like 5 people who could do this, because if you had 10 people, it would bog it down too much and it would be very slow. Let's go ahead and go to the next slide. But those strengths mattered. So machine learning, data science, a limited scale, streaming data, semi-structured data, the ability to do schema on read, that gave you a lot of flexibility. So this is powerful, but it's all kind of isolated by itself, the data lake and the data warehouse, and each has its own strengths. And a lot of people thought, well, the data lake will replace the data warehouse. We just won't need it anymore. We'll be able to do everything with the data lake. That's not quite the way it happened, because the weaknesses of the data lake and the weaknesses of the data warehouse and the strengths of both meant the best way to do things was to use both. So go ahead and go to the next slide. So what you saw was this cooperative data architecture in more and more companies where you had a little bit of each. So you had your data warehouse sitting next to your data lake, and you would throw all your data, your historical data in your data warehouse, and you would do some ETL with something like Spark, and you'd put it in something like Parquet or Orc. Now, Parquet this is a really cool format. You can store data efficiently long term, but it's also columnar, so you can query it, and you can do machine learning on it, and so that was pretty cool. And so over time, what has also happened is, while the data lake folks have tried really hard to add SQL capabilities and governance and security and some of the other things that you got from the data warehouse to make the data lake more functional, the data warehouse folks, the database folks, they went, well, look at these new formats. Those are cool. We can use those. We can inhale Kafka and JSON and Avro, and we can read and write and import and export Parquet and Orc, and it's like, okay. And then you can do machine learning and geospatial and time series analysis and data preparation, things like outlier detection and all this other stuff in your database. And you can do SQL and several other things in your data lake. So the differences between the two have become less and less, but the strengths are still there, and people are still sort of historically thinking, I only do BI in this place, and I only do data science in this place. So there's almost like a procedural spiritual kind of thing that says I have to do this in this place or that place, as opposed to the technology, which has progressed to be more and more the same. Next slide. So what you see with this cooperative architecture is the strengths of both worlds. Now I want to go ahead and go to the next slide, because you've already seen all these strengths, and give you an example. So this is a real world example. This is Uber, and they have over 100 petabytes. They're gigantic, and they have a huge team, and they have this cooperative architecture, and they have it for a reason, because they started with just the database, just a data warehouse of Vertica. I work for Vertica, and they're one of the sponsors of this. Go check out the booth when you get a chance. And then they realized they needed some of the power of the data lake, and they thought, this is awesome. The data lake is the best, and we will replace our data warehouse with a data lake. And it didn't quite work out that way. In fact, as Vertica absorbed much of the capabilities of the data lake, it actually, they found that geospatial analytics was easier to do in the database than it was in the data lake. So they started doing that there. And they've done data exploration in the data lake. So that's easier to do there. And so they found that they had to combine the two. But they also found they needed to isolate their workloads, because the last thing you want is for your machine learning to slow down your BI, or for your BI to slow down your machine learning. You don't want them to bump against each other and compete for resources. So let's look at the next slide. So Simplifi is a smaller company. They don't have bukus of data like Uber does. They have a pretty significant amount, but they have enough that while they throw it into a data lake and do a little prep on that to make it good and clean, they throw everything into their database. And the reason they do that is because their use case requires sub-second response. They need an answer and a reaction to happen. It's all AI and machine learning based, and they need it to all happen in 200 milliseconds. In order for that to happen, they need the speed of the database and the concurrency of the database, because this is their bread and butter for this company, and they're doing it hundreds of times per second, and they are doing it all across the web. So in order to accomplish that, they need a database that is dedicated to nothing but their bread and butter. Okay, well, they still need to do BI. So they're doing, some data prep, some aggregation, things like that. And then now this is the second one is actually their data warehouse. That's where they're doing BI. And then they're like, well, the executives like to have their dashboards and they don't want my, ad hoc query that I'm doing in the BI database to drill down on that. And so it's like you end up with 3 different databases and all of these pipelines to try and build them all, but they never have to worry about these workloads interfering with each other. So you have perfect isolation of workloads and they get their sub-second response, they get their BI, they get their dashboards. And that's cool. But it's a lot of pipeline. And the same thing with Uber. Go ahead and go to the next slide. They have a very complicated solution. It works, but it's a little bit hard to maintain. You have a lot going on there. So what has happened over time is the data lake folks have moved more and more towards absorbing the capabilities of the database. The database folks have moved more and more towards absorbing the capabilities of the data lake. And on the data warehouse side, we call it the unified analytics warehouse. On the data lake side, they call it the lake house, which, okay, I think that's a little silly. It's like where data goes for vacation, but that's my opinion. But the cool thing about this concept is you can get workload isolation by having subclusters. You can put it anywhere, on-prem, on the cloud, any cloud. We even support Alibaba, which isn't on the slide. Any hardware, anything with a Linux operating system, pretty much. And you can support virtually any kind of data because there is actually a data lake as part of it. So you can throw all your data in there, do your refinement with Spark or whatever, put it in Parquet, and then we can read and write that directly, or you can refine it further and put it in the database format and get that high-speed response. And you can do your machine learning there. You can find your outliers and balance your data sets and find your correlation matrices and do your, evaluate your models, all of that in the database, which means I get full accuracy because the only sampling I do is for training and verification samples, which I can do with a single line of code and it's done. And I can do that in SQL, I can do that in Jupyter, I can do that in Python. It's up to me. And if I build an algorithm in Python or R, it will automatically distribute it across the database. Well, since this is a scalable database, this isn't one of those single node things. And I can do all of that in one place. So when I'm going to production, it's exactly the same. My dev, my test, my production are identical. It takes a single line of code to move to production, not a multi-month project to get my data science into production where it can make some difference. So go to the next slide. So you kind of see the power of it is we're not worried about where you store your data. You want to store it in the data lake, you want to store it in the data warehouse. That's up to you. What you want is the strengths of both, and you want to be able to unify your analytics so that you can do all of your analytics in one place. Whether it's BI, whether it's data science, doesn't matter. You should be able to do the analytics with your tool of choice and not worry about where somebody stored your data. So go to the next slide. So here's a couple of examples. Now, the first one is actually, this is United Group, and they've been in production for a while. So they didn't actually, they don't have a data lake in there. So they went straight to the database. And because it's scalable and affordable, they don't really need a data lake for their size of data. And they're doing everything in SQL. They're doing a little bit in Python too, some machine learning and stuff in there, which I forgot to put on the slide. Sorry about that. But most of it is SQL and Python and done in the database without any aspect of a data lake. But because they're doing all the things that a data lake normally does, they're storing high velocity data. They're doing their transformation. They're doing machine learning, all of that stuff. That's what I'm talking about, a unified analytics warehouse. But the next example, next slide, is actually, I think, ideal. It's really, these guys have not been in production as long, but they are at a fairly high scale. They're doing 15 petabytes of data on the Amazon cloud. And they are putting it all in a data lake, in the Amazon S3 format, I mean in S3 location, and then they're refining it to Parquet. And then they have one cluster that does all of their machine learning and everything. And then they have a couple of clusters, 320 nodes each, that they spin up once a day and do their reporting with. And then when they're done, they spin that down again because they don't want to pay for that compute. So that gives you amazing capabilities that combine the abilities of the data lake and the data warehouse and give you workload isolation. So that's the advantage, I think. Go ahead and the next slide of the unified analytics warehouse concept is that you get both of the strengths of both worlds. Now, EMA wrote a white paper recently called The Race for a Unified Analytics Warehouse, talking about how that race for the middle works. And I'd love it if you would go and check that out. I also created a breakout room if you have any questions, because I knew I was going to have to talk really fast to get this in 20 minutes. And we have a Vertica booth if you would like to check that out. So if you guys have any questions, you can, I have some time left. So feel free to ask me in the chat, or we can go over to the breakout room and do it in person. It's up to you. And I know there's an 8-second lag between me talking and you asking something. So that's one of the advantages of the breakout room, is it's in real time, whereas the chat has this lag. Now, I also put a link to a blog post that I did a while back on my personal blog, Big Data Paige, that talks about the Uber journey, where they went from a Vertica database to trying to do everything with a data lake and Presto to realizing that they needed both. And one of the interesting things about that now is that they are moving forward into a unified analytics warehouse on Google Cloud, because they've changed where they want to put it, and they're now starting to combine those into that unified analytics warehouse. It looks more like the Trade Desk kind of architecture. So I can't believe I did all this and I still have a couple minutes left. When I was practicing, I actually kept going over time. So it's funny how you get in live and you go really fast. If anybody would like to ask a question, I am live over in the breakout, and or I don't see anything on the chat. You guys you gave me lots of good thumbs up. I really appreciate that. But feel free to ask a question. There's always something. Or not. All right. Well, I will hang out in the breakout room for just a little while and see if anybody shows up. And feel free to go check out the Vertica booth. And there will be a couple of people there for the rest of the day to answer your questions there, in case you're curious about how this works and want to get more information. So thank you guys for coming.